Okay, let's start the session today. Thank you so much for joining in. Welcome back after a brief puja holidays. Hope all of you had nice Deepavali and you enjoyed your puja time. Welcome back. Today our topic is as we are approaching the final journey towards closure of some of the sessions now. Today we are going to cover network forensics. Now, network has got, multiple dimensions of analysis. Network forensics, the word itself is a very interesting as a concept. So, let's delve into the capability of network forensics. So, network forensics, when we talk about it, anything that flows inside the pipes of the network, whether it is wide network or it is a Wi-Fi network. The data in bit and byte format traverse across the network. And that piece of information travels in something known as packet, which is the fundamental unit of data transmitted over a network. Now, a typical packet has got a well-defined, information which includes control information and user data. If you remember your old engineering days, in a typical study of network, the lowest level of information which goes over the network is packet. Now, within the packet, there are raw data which is known as payloads, and there are some control information which is known as header file. So, when you go into the paradigm of network forensics, it's always good to understand the packet structure, which is crucial in network forensics for analyzing the data and determining the nature of the traffic. Hope I am audible to all of you. You can unmute yourself and speak. One of you can speak.
Yes, sir.
Wonderful.
All okay.
Yes, sir. All okay, sir.
Thank you so much. I'd say number are amazing today. 60 odd people. I think you all needed a break and you got it. So almost 62 people are there in the session. So that's good. So when it comes to, dissecting a network data, the packet becomes the most critical factor for comprehending the entire information within the network. Now, there are a couple of challenges that, a network forensics, personnel, encounters. Because unlike earlier days, most of the information which travels on the network uses some sort of encryptions in the pipeline, which is known as data in motion. Mostly this data in motions, gets encrypted. So carrying out a packet interception is not an easy work anymore. It's very complex work. Please mute yourself, otherwise, I'll be forced to mute you all. Okay, so that's a challenge part of the packet. Even if you can intercept the packet, and there are ways of doing the interception of the packets. You can store the packets, but when it comes to the analysis, the raw data, which is your payload, actually many times it encounters a level of encryptions, which becomes, a dark area for your analysis. Yet the packet has got content information, which is control information, which is header file. It does not get encrypted, and many times those informations are used for dissecting the packets and comprehending some information which are available as a part of the packet header. So as I spoke, there are two dimensions of a packet. One is the control information, and the second is the user data, which is the payload. Now, when you do the packet, the studying, but before that, you need to sniff these packets. Think about it, the packet is transmitting at the speed of gigabyte nowadays. If you are using 5G, it goes at the speed of gigabyte, 1 gig per second. So 1 Gbps speed is a huge speed. So you need something to tap these packets for further analysis. That tap is known as sniffer. It's like a tool. Many times it is in a corporate information organizations where the packet sensors are there. They are hardware-based tools, which is known as tap. But there are a lot of software-based, interceptions are possible. So sniffers can be used both for legitimate network management or for malicious data interception. And the malware writers, the hackers, they intercept the packets to analyze the nature of traffic and try to find out what sort of environment is there within the organization, what version of SSL traffic is moving, what encryptions are being used, and that provides you a significant amount of information about the network itself. So when it comes to a typical packet, we can divide the packet into 3 layers. One layer is known as Ethernet header. Now, Ethernet header is typically a destination MAC address, which is 6 bytes of information, which identifies the receiving device. So if I am sending a packet to you, your destination MAC address is defined in the packet itself, because then the packet knows where it has to reach. Then it also carries source MAC address, which identifies the sending device. And then there are 2 bytes of informations are there, which indicates what protocol it is carrying, whether it is IP protocol or ARP protocol. It is defined by that type, which is 2 bytes. So when it comes to IP header, it is carrying a lot of information about the control information, which we discuss as a part of packets. So it talks about, the first thing that it talks about, whether it is IPv4 header or IPv6 headers. Now, IPv4 header is typically a 32-bit information. But when it comes to the IPv6, it is almost around 128-bit information. It is 4 times bigger than that, actually. 128-bit, information is there. Then it has got a very interesting thing, which is known as 4 bits of IHL header, which is internet header length. And then there are a lot of informations are there embedded as a part of.
ఇంకా టీవీ ఆడుతున్నాం ఇప్పుడు అప్పుడే మరే టీవీ మరే
Now you all can't speak. I've just put you all on permanent mute. So any information, if you can't hear me, you can use the chat window or your gestures to communicate. Otherwise, it disrupts the classrooms. A bit of being disciplined is important for online sessions. Otherwise, it distracts the class altogether. One person makes the mistakes and rest of the people suffers. Okay, so within the IP header, I can send some information on the screen. Let me see if I can. Give me just 1 second. Make it shareable. Unfortunately, I'm unable to share my screen further, so stop here. So it is very important for all of us, if we really want to be a good personnel for network forensics, the 2 dimension of network has to be understood in entirety. One is the network itself is a huge subject, and then dissecting the packets and learning from the packet what is there inside the packet. And as I spoke earlier, it has got 3 dimensions. One is Ethernet header. The second one is Internet Protocol header. And the last one, if it is a TCP or UDP header. Now, one must understand that, the network is not as simple as just typing in the internet and you are getting back the information. There are a lot of complex technologies within it. So every time when you interact on the network, it has got something known as protocol. Now, all these protocols define how the information will look like. To dissect that protocol, how you will use it. So network forensics, requires real deep understanding of the network. While I'm going to give you a detailed work how we can achieve the network forensics using tools, you may or you may not understand based on your understanding of the network. If you understand the network technologies in detail, possibly network forensics will be a cakewalk for you. If you do not understand the network and the network technologies, you may understand how to do the forensics, but you may not be able to really master the art of network forensics. So for every learner, it is good to understand network as a part of the journey to become an expert on network forensics. While networking is outside the preview of today's class, so we'll just skip some portion of network, particularly from packet side we are covering, but we may not cover you the entire detail, how to dissect the IPv packets, what is there inside it, how to read it. It will be very difficult unless you know the subject network technologies very well. Okay. So one very important component of the network, which is IP header, has got many information. So it tells you precisely what is the versions, whether it is IPv4 or IPv6. What is the internet header length? Is it 32-bit, 128-bit, 64-bit? What is that? Then what is the type of service it indicates? Type of service is all about the quality of service, service that it indicates. What is the total length of the packet, length of the entire IP packet? Then identification. What is the UID of that packet? Because every packet comes with a unique ID. So what is the UID of that packet? Then there is something known as fragmentation flags. Because when the packet comes, it does not carry all the information in one. So one packet will be a very small unit. Many packets together will form the information. So not only it carries unique identifier for each part of the packet, which joins together to make a information, it also carries some flags for controlling and fragmentation flags. Okay. And there is something known as fragment offset, which is the position of the fragment in the original packet. Because if the packet has got, around 16, chunks of information available, every chunk will have a number, unique numbers attached to that. So now when you are actually adding all the components of packets together into one piece of information, this packet need to be arranged in a serial numbers. So fragment offset also provides the what particular position of that particular piece of packet represents among the total chunk of the packets. And then there is something known as time to leave, limits the packet's lifetime. Then it has got 8-bit dedicated for protocol. What protocol it is? Is it TCP protocol? It is UDP protocol? It is SMTP protocol? And there are many such protocols are there. More than 3,000 protocols are there. You can go and search in the Google, you will find around 2,500 to 3,000 protocols are there. It precisely provides you information about the protocols. Then every packet carries some information which is known as header checksum, error checking for the header file. Okay. And then one very important piece of information, the source IP address, because anything which is moving from one side to another side, you need to know where it has come from. So suppose if I'm sending a packet to you, my IP address will traverse along with it. And then where it has to reach that packet, so a destination IP address is also written. which is the address of the receiver. And finally, you have got, TCP and UDP headers. Now, the file is TCP file or it is a UDP file. Now, from network perspective, the difference between TCP file and network, UDP file is that, one is the TCP is a connection-oriented protocol and UDP is a connectionless protocol. And we need to understand, the TCP, why TCP is connection-oriented. The reason is that, TCP guarantees transmission of the packet and confirming the information I reached to the destination in entirety. And UDP just ensure the packet has been sent to a destination. It does not confirm you whether it has received by the other side correctly or not. It does not guarantee you. If you compare it with, normal mail and a barang mail, the normal registered mail will be that, the mail will reach a destination, acknowledgement will come back to the sender. It confirms the registered mail has reached to the person. But a connection mail, connectionless protocol is like that I have sent a postcard or I have sent a barang mail with an address, whether it has been received or not, there is no guarantee, but chances are 99% it will reach. But if it fails, no guarantee to that actually. So TCP headers or UDP headers has got certain components built into in addition to the normal IP headers, which include source ports, what particular port it is going. Is it a SSL port, port 443, or it is port 80, or it is port 21, which is FTP port, or it also tells the very, very, important component, what is the destination ports also. So which particular port it is going and which particular port it is coming. So both are defined as a part of the TCP and UDP headers. And then there are some additional fields as a part of the TCP or UDP. UDP has got length and checksums. It does not have acknowledgement, so it does not have acknowledgement numbers. TCP has got sequence and acknowledgement numbers, window size and checksums. Acknowledgement number is there because, the handshake between the TCP packets is three-way handshake. A SYN packet is sent, acknowledgement is received, then final acknowledgement of guaranteed communication begins. But in case of UDP, the message is sent from one side to another side, length and checksums are there, but there is no guarantee acknowledgement will come back from there. Now, there are many things in the packet forensics, which is required to be known. Now, suppose when you are doing a forensics of a network packet or analysis of a network packet, there are certain information which clearly provide what sort of, encryptions are being used in that particular packet, what sort of SSLs are being used, secure socket layers are being utilized, which particular port it is using, is it port 4444, 443 for HTTPS, or is it a simple port 80 traffic, which is a clear text, format the informations are going. If it is an SSL TLS, it tells you, what particular version of SSL and TLSs are there. It even identify this, TLS or SSL, versions, if it is TLS 1.2 or TLS 1.3, or it is SSL 1.0 or 1.3 or 3.0, all these informations are there in the packet header and it can be identified. So, ladies and gentlemen, the packet capture is a long journey, and then analysis is also a great journey actually. If you look into the history of, packet capture, or network forensics, I don't know how true statement is there, but I found one document which talks about late 70s, 78, 79 time frame and early part of 1980s. That was a time when actually network forensic originated, and the need was for monitoring and diagnosing the network related problems. And that time, the primarily focus on performance issues and error detection in network communications. That was the reason, packet capture become an integral part of, communication management and performance management for the network. When the growth of internet started happening across the globe in 1990, internet expanded, and with the expansion of the internet, there was a need for monitoring network traffic for security reasons. And that was the time when the intrusion detection system came into the place, which actually uses network forensic techniques to identify the packet and see the anomaly within the packets and block the packet if there is a malicious traffic. But real advance of technology has started happening in 2000 to 2010 time period. A lot of new development tool for sophisticated network forensics started being created. Hardware-based forensics and both software-based forensics become very, very prominent in early 90s. And 2000 to 2010, it got matured completely. I remember that, I used the first time the packet capture. Earlier, it used to be TCP dump, and then PKF file, we used to get it in early part of 2001, 2002. I used it, for packet capture and deciphering the packet, what is there inside the packet. But real emphasis on real-time analysis and automated threat defense started in the late part of 2010 time frame, and by 2015 it matured completely. Now, almost every large organization can boast of network forensics as a part of the malware detection capabilities, comprehending the packet, detonating the packets, understanding what is there inside the packet, and predicting uses the malware-related behavior. So, ladies and gentlemen, that's a pretty brief about today's session. And I'll expect Akash to take it over from here. Akash, are you there to do some practicals so that class becomes lively?
Yes, sir.
Wonderful.
Am I audible?
Not very clearly here.
Yes, sir.
Some sound issue is there. Now you are on mute. So, ladies and gentlemen, when it comes to before the class begins, there are 4 dimensions of a packet-based, forensics. First one is the capturing the packet. Normally, open source tools, Wireshark and TCP dump, it provides a significant amount of information about that. And then analyzing the packet capture, which is built-in tool is network miner. And then, you can do the packet capture analysis with PCAP X-ray or online PCAP analysis, you can do it. So, only challenge with the packet is that, volume of a packet becomes so big sometimes, it is very difficult to store it because it goes in gigabyte every half an hour, 45-minute time for a large corporate network. You require significant amount of storage and analytics capability. But with the advent of the NoSQL engines and cheap, storage devices, now many people have started capturing the packets and storing it for 7 to 10 days time and carry out the detailed packet forensics over a period of time.
I'm audible also.
Yes, you are audible.
So let me share my screen first. Yeah. So as sir have spoken about the network trafficking, so the all the data which transmit over the internet is gone through in the form of packets. So as we have the internet speed is the Gbps, Mbps. So these packets are of very small size. We can't even study all the packets at same time. We have to make a captured file for to analyze these packets for the further. All So we have some tools, or we can say some commands which we can use to we can see the internet trafficking, or we can say we can see the packet transfers between the devices, or also we can capture these packets into a file for the further analysis of this traffic. So first we have a tool which is POF, or we can say P0F.
Akash, your screen is visible, but are you typing some command? Then it is not
No,
visible.
sir. I'm not typing anything, sir. Yeah. So first we have the POF tool. POF is a passive OS fingerprinting tool which is available in Kali Linux. It allows you to identify the operating system of networked hosts based on their observations. To use the POF tool in Kali Linux, we have first we will go through the manual of the POF tool using manual POF. Here we have the manual, and these are we can go through the manual to know more about the POF tool. Let me quit this, and also we can go through the POF help. Here we have some more options, that we have network interface options, operating mode options, output options, and another options for the POF tool. The POF tool will show you the connections between the connections of you over the internet. I suppose I want to, let's, for example, I want to connect with the google.com, and for that, how, how many packets I will transfer to, from which is the server side, which is the client side IP, and all the information we can get by using the POF tool. To basic syntax to start the POF tool, we have, we will type POF, then we will hit enter. As you can see, uh, it got started. Here we have some information initially, and this is my IP. We have the client side IP, that is this, and also the main benefit of the POF tool is that it will also show you the operating system of the client side or the server side, which is at that time we have Linux, and another informations like the the packet we are transferring, another things like links, and another crucial information that we are transmitting over the internet. I suppose for example, I go to the browser, and I suppose I want to go to the google.com. I will type www.google.com. Now we have reached to the google.com. As we go to the my terminal, we can see there are some more information got there. We have some information like this is my my client ID, and this is the IP address for which we are sending the packets. Here we have my ID, and I am sending the SYN packet to this particular IP. So as we have go through the google.com, this IP will be the Google's IP. For check this, let me copy this. And here we have also the some also more informations that what the packets we have transferred, what the information we got from the server side. As you can see, here we have some that the informations this packet captured that came from the server side, which the server side IP is this. Let me terminate this and check the as we terminate the process, we have seen that we have proceeded 8 8491 packets in that particular time in that the POF tool is run. As we have go through the google.com, let's check that IP address we have displayed here is of google.com or not. This we can check is by using who is, then we will provide the IP address. As you can see, here we have some informations about the IP address. As you can see, the net name is the Google, which shows this IP is for the google.com. By this, we can confirm our POF tool. As we have already talked about the interfaces in our system. In Linux classes, I have told you about the interfaces in our system. We can see the interfaces in our system by using ifconfig command. Here we have some interfaces just like docker 0, if 0, and wlan 0. These are the interfaces in my system. You can specify the interface in the pure command by using pof dash I, and we can give the interface name. I suppose we will give wlan 0. Now it will capture only the packets which are going from that interface or that are coming to that interface. By this we can use the interfaces into the pure command. We can also use the dash l option. Yes. It will show you the all the interfaces that your system contains. Here we have the w wlan 0, the IP address. Another systems are interfaces are there. We can also capture the packets which are going or coming by the Bluetooth by using the that interface name. Suppose I have connected my Bluetooth device and I want to capture the packets which are transmitting through the Bluetooth. By we can use the that interface name to capture such packets. So moving ahead, we have on another tool which is Wireshark. So the Wireshark is very popular and a well-known tool which is used to packet analyze, and it is also used to capture the packets into a file. It is the pre-install tool in Linux. The Wireshark is widely used tool. It is a GUI tool which is very user-friendly interface. We have very some the Wireshark comes with very useful features like it will supports multiple protocols, just like it will support TCP, UDP, HTTP, and other protocols. And in this, you can see the details of the each packets that is transmitting over the internet. As it, as in the POF, we can't get the more detail about each packet, but in the Wireshark, we can have the all the information, detailed information about each and every packets that are coming or going from our system. The another important feature of the Wireshark is the color coding. Wiresharks use color coding to highlight the different type of traffic making it will make it easier to identify the protocols, issues, and another analogs on the network. It will give you the statics and graphs by which you can easily analyze, and it will help you to analyze network performance, identify the trends, and it will also help you to troubleshoot the issues. And at last, the Wireshark will can also export the data, as we have already said. It We can capture the packets by using Wireshark. It will convert into some files which you can further analyze by using other tools. So let's go through the Wireshark and see how it will work, and how we can see the packet, and also how we can capture those packets to further analytics. To go through the Wireshark, we can type the Wireshark, or we can go through the applications, and we go there, those spoofing and sniffing, and here we have the Wireshark there. Why why as you can see, we have opened the Wireshark here. Before before going to the Wireshark, you must have to know about interfaces of your system. This we have if config. We have some interfaces there. We have information about which interface that you are using to analyze or see the packets. For today, we are using the line 0 to practice purpose. Here, this is the home page of the Wireshark. Here in the topmost corner, in the header of the Wireshark, we have some buttons which you can. Here we have to. We have some options, and as we have there we have some all the interface of our system. As you can see, here we have line 0, and another just like Bluetooth 0. As you can see, there we have a graph which is showing that that trafficking is going on in that interface. To see all the packets and the information about the packets for a particular interface, we will double click on the interface. As there we have line 0, we will double click on it. Let me zoom in. As you can see, here we have the numbers of the packets. It will start from the 1, 2, 3, 4, and so on. The time from which we have started the Wireshark, it is from the 0th time. The first packet is that, and so it will you can get all the packets that will transmit, or we can or received at the interface you have chosen. Here we have some options like here. This is used to start capture packets. This will use to stop the capturing packet. This will use to restart, and this will use to search in the specific package you want to search. I, let's suppose I want to search number 12 packet. You can search from there. Then we can go through the next packet by using this, previous packet by this. Here we have some, as you can see, some packets contain a different color. That's this. The third packet is of pink color. This is the beauty of the Fireshark. It will use color coding to identify the different packets, which will make the study of packet easier. By this you can by this button you can undraw the color coding. By this we can zoom in, zoom out, normal. And there are some of the options which we can use to using the Wireshark. As there we have the numbers of the number of the packets, then we have the time at which time the packets transmit or to come transmit. The source IP we have there, the destination IP we have there. Also we have the protocol. As well, let's say this is TCP protocol using this packets using TCP protocol. This is also using TCP protocol. The length of packet and the more information about the packet. To know more about a particular packet, I suppose know I want to see the information about that packet. We will click on this, and at the right, at the left, we have the more information about that particular packet, just like the size of the packets. As you can see, 5 to 8 bytes, interface name, ID, then we have the source IP, destination IP, then we have the protocol name, source port number, then destination port number. If we click on this, we have more information, just like there are the data which are transmitting through the packets, just like this. We can analyze each and every packets one by one by using the Wireshark. As you can see, a single packet contains very much information, and if we go down in such few minutes, as you can see, there are around thousands of packets that Wireshark has been captured. It is like impossible to go through all the packet at the same time or at the transmitting time. For that purpose, we have to keep the packet record, or we can say we have to capture all these packets for our further analytics. The Wireshark provide us this capability. As you can see, there we have around 57,000 packets we have captured there in Wireshark. From the number you can imagine how this will gonna difficult to go through all the packets. For that we can capture the packet by using the Wireshark. To capture the such let's suppose I want to capture the all the transmission of the packet. We will stop the capturing, and then we will save file, as then we will provide the name, I suppose test, and here we have the file type. We will save it as pcap file. The pcap format is used for the to store the packet informations. We can save that by using Wireshark as we open the file manager. Here in the document folder we have the test.pcap file. This pcap file will contain all the information about those 65,833 packets are contained in that text.pcap file. This is how we can use the Wireshark to analyze and to capture the packets that are transmitting through from the surface to the from the interface, or the packets that are coming to an interface. Till now, if anyone have any doubts, you can ask. So let's continue. So the so next we have another tool which is Nmap. Nmap is a very useful tool to network forensics. It is used to information gathering and the fingerprinting. Now we will use the Nmap tool to gather information about the resources and device on the network and discover any open filter or the closed ports, and fingerprint also fingerprint their operating system. Nmap is basically used to gather information about any network. Suppose I have my network, I have an IP address, and to gather information about that particular network, which which ports that network is using, which are closed ports, which are the open ports, and the fingerprint of their operating systems. These we can easily get by using the nmap. Nmap is every system, Linux system have the nmap installed. The basic to first we will go through the manual of the nmap. Here we have the manual of the nmap. It is nmap is also a port scanner tool which is used to scan the ports of any IP address. Here nmap is used is a network mapper. It's also an open source tool. Here you can go through the manual to know more about the nmap. You will quite here, and by going into the applications, we also have the nmap here. Here we have the help for the nmap. Nmap is a very used tool. You have to give the focus your focus on the nmap to gather the information about any network. So nmap tool is very important and very useful also. So basic syntax for the nmap is, I suppose I want to gather the information about a network and I have the IP address of that network. We will use the nmap to gather the network information about that particular IP address. We will use nmap, and we will provide the IP address. For say I will provide 8.8.8, which is a Google IP, as you can all know. As you can see, starting nmap, here we have the version number, and as a result, here we have the scan report for that particular IP address, and also we have the DNS. It is showing it scan thousands of ports, thousand ports of that particular IP address, and it show 998 filtered TCP ports. We got no response from these 998 ports, and here we have two ports which are 53 and 443, which is in open state, and the service of that these ports are the domain service and the HTTP service, and these ports are open for the TCP protocol, and in the end of the result we have the nmap done. One IP address is scanned and the scan time is there. Let me clear this. Let's try the nmap by using the more options in the nmap. In nmap we have an option which is -sv, which is used to identify the running ports, or we can say the open ports on any network. First we have the 8.8.8.8, and I have this IP address, or we can say I have this network, and I want to see all the open ports into of that network. We will use dash sv in a and map to know that to know open ports. As you can see, starting and map, it goes started. It will scan all the ports and give the result as which ports are open. I think it will take some more time. Let me terminate this here, and we will use some more option. We will not waste time on that. So another option in the nmap we have. Suppose if you want to scan some particular ports of that of a network. Suppose I want to scan 100 ports of a network. In nmap we can use dash p option, and then we will provide the number of ports, how many number of ports we want to scan. Let's put 100 there, and then we will give the IP address and hit enter. As you can see, it start, and we got the output here. The host is up, and it will filter 999 filter. It will go through the 999 now. It will go through the 99 TCP ports, and it got no result, and it we got a TCP port open at port number 53 which contain domain services. To get information about the operating system fingerprinting by nmap, we will use
Team, sorry
nmap.
for a small interruption. There is an attendance sheet is there. Please fill it up, as the class continues.
Yeah. So to know about the OS fingerprinting of any network, we will use the dash O option. And we will provide the address here. Let's start. The nmap is started. Here we have our result. As there we have some informations, and we have the no exact operate OS machine matches for the host. We don't have the exact OS matches for that particular network. By this you can go through the get the OS fingerprinting by nmap. Suppose if you want to scan only UDP ports, for that we will use nmap dash su, and we will provide the IP address. As in the result, we have those two UDP ports which are the 53 which with the number 53 and 33459. One is in open state and one is in closed state. The service, we have the first one, we have the domain service, another is with unknown service. We can also put all the, we can also use nmap to scan multiple IP address, or we can say to scan multiple network at a time. For that, we will use nmap, and then we will provide the IP addresses. The first we have 8.8.8. Then we can provide another IP address. Let's suppose we provide this. This is my system network IP address, and further you can provide the IP address as many you want to scan, and uh, as output we have the nmap scan report for the data IP address and nmap scan report for data IP address. Uh, you can also save the scan report in a txt file by using nmap dash on. Then we will give the file name. Suppose we give test.txt. Then we will provide the IP address. IP address we have 8.8.8, and we will hit enter. Now, if we open our file system, here we have the test.txt file, and it contains the data, the test report, which we got by using nmap. Nmap contains multiple options. You can go through the help, and you can use all the options to filter your search and to get more efficient result. I have forgot something in the Wireshark. The Wireshark also contain a very important and the most useful feature in it, which is the filter option. We can apply the filters in the Wireshark. Let me zoom in. I, here we have some of the filters. Some of the filters which are present in the Wireshark. Here we have the filter name and the filter expression. Suppose I want to see only packets which contain TCP protocol, or I can or I want to see the packets which contain HTTP protocols, ARP protocols. We can specify the filters to the Wireshark to make our result more beneficial for us. Suppose I want to see all the TCP protocols, then we will give TCP and Here we have all the packets which are of TCP protocol. By this you can apply the filters. By filters, it will more easier to go through the packets and the search into the packets. If you have any doubt about the Nmap, Wireshark and the POF, you can ask now. As I have already told, the POF and the Wiresharks have the big difference in it. Let me show you. If we use POF, then we got only some minor information about the packets. Suppose this is a packet, it will showing the source IP, destination IP, and the type, and few more things. And if you use Wireshark, let me show you. It captures the packets, and also it will it will capture the informations which are transmitting through the packets. Let's say it captures the packet. Here we have the size of packet, which is the 52 bytes, and it will capture all the information that a packet contains. That's what you have log into some website. You have sent your credentials for that website. Those are going through the by the packets. The voice Wireshark will capture that packet, and it Wireshark basically can capture the packet, proper packet, but the POF only show you the information about a packet. So we will talk about that tomorrow. Um, what we can get from the packets which we have captured from the Wireshark. We will have a session tomorrow. We will talk about how we can read the packets which we have captured, and also we will see how we can analyze the pcap file which we have captured by using Wireshark, and how we can get the data from those packets.
Okay, so team, ladies and gentlemen, so there are some questions, which has been posed as a part of the session today. So one of the session is वायरसार्क डाटा में क्या देखने वाली चीज है और कैसे पता चलेगा. So as I spoke that, Wireshark data is your packet capture. So, and packet has got two components. One is the control file, which is your header file. And then there is second part is the payload. Now, payload, if it's in clear text format, you can open the file and see what is going inside the packet. If it is encrypted file, then you cannot say anything in the packet unless you have the keys with you. The second component is the control file, which is your header file. Header file provides you a lot of information about the packet itself. So it all depends, if you know how to, read the packets, which is a prerequisite for knowing the network forensics analysis. So if you have not visited the packet, please do visit the packets. Refresh your, networking components and then learn how to read the packets. If you are new to it, I think your journey begins with the networking itself. Because you may not be able to dissect even if I tell you how to dissect the packets, you know how to do it now, but you may not be able to read the packets, correctly unless you understand what is there inside the packets. So my request will be that, I have shared some content to you as a part of Linux forensics content. Go through that and also try to go and learn a little bit more on the packet side itself, how to dissect a packet. Okay. The one question was at the beginning, it was a very interesting question. Kindly throw light on DDoS attack and what are the parameters to be considered. It is from Kirthana Balaji. Okay. So let me give you some insights around. So there are a lot of different type of DDoS. So there is something known as volumetric DDoS. So distributed denial of service attack, is a typical attack where they use, a very interesting technique to flood your network with significantly large amount of, access to the network. If your network can handle 1,000 people, 1 million people will come to your house. What will happen? Now, 1,000 you can handle in your house, or 1 million people come to your house, what will happen? It will be very difficult to hold all those people together, and there are many people who will remain outside. They will not be able to come in. And in the process, many genuine people who really wanted to meet you, they will not be able to meet you. So a typical, DDoS attack has got many components, but one component I'll share with you today. It's how to manipulate the TCP handshake. Okay, most of the traffic happens on HTTPS traffic or HTTP traffic, and the packets, when it reaches you in a typical TCP IP protocol, the three-way handshake happens. The first packet the attacker will send you, it will be, SYN packet, SYN packet, which is synchronized packet. It sends you the packet. Then you respond to that packet with an acknowledgement from your side. Now, I have a choice to send back the information to you, or I'll just hold the information. I'll not send you the acknowledgement, and you will keep waiting till the time packet gets dropped. Now, this is one of the technique when the millions of SYN packets are sent, same time, you send the acknowledgement packet back to the attacker, and attacker does not send you the final packet to acknowledge whether the session is established or not. Then your machine goes in hang conditions due to very large number of SYN packets. So that is one of the attacks which happens. So suppose if you have SYN packets which are more than 10 seconds old or 20 seconds, 30 seconds old, or nothing is coming from other side, you can drop those packets, and you can reduce your DDoS attacks. So that is one technique, which is used for DDoS. While there are many techniques, which are, application-based DDoS are there, which requires a lot of complex study of, layer 7 attacks. But this is one of the easiest attack which is carried out using run you to death, Rudy-based cyber attack. Okay. Docker is virtualization to which elements requirement of guest OS. Okay. Where is the message hidden in the packet? So packet has got two component. One component is definitely, the header file, which is control file. The second part of the packet is a payload. That is where the information lies. So if you want to read the information, you have to look into the payloads. And if you want to read the control file, the header file, the metadata, data about the data, then it lies in the header file. Okay, I think no more question. Any question from any one of you? Okay, let me unmute yourself, otherwise you'll not be able to speak. Give me 1 second. Yeah, now you want to speak, you can unmute yourself and speak.